we have a quadratic polynomial that has a lead term that is not 1. And that makes it a little trickier to factor than other polynomials that don't have a lead coefficient other than 1. There's a couple of ways you can approach it. If it is a prime number, it makes it fairly easy to go ahead and do trial and error most of the time, because the first term, 3x squared, is only going to factor out one way, and that would be 3x times x. Next, you would want to look at the signs on your last term, which when your last term, to get your last term, you would have multiplied the two last numbers inside each parenthesis. So they would have had to have the same sign if you get a positive product, which means they could both be positive or they could both be negative. But the middle term is where you would have combined those two numbers by adding. So when adding, if you end up with a positive, it means both of the numbers, if both of the numbers have the same sign and you end up with a positive, it would mean that both of the numbers were positive. If both of the numbers had the same sign and you add them and get a negative, it would mean that both of the numbers had a negative sign. So by looking at the last term's sign and the middle term's sign, I know that I should have a positive in each set of parentheses. Now that I've figured out that much of it, I can focus on getting those last two numbers for each set of parentheses. So I'm going to take the factors of 16 and think of all the different ways that I could have a factor pair that would give me 16. And from here, I'm going to do trial and error. So I recommend trying the pair that is the most close to each other, the two numbers that are closest to each other, just because it's very common for that to be what works. And then you're going to do little smile, big smile. So you're going to go little smile to get positive 4x, big smile to get positive 12x, and then you'll have positive 16x, which is my middle term. So that is what we want, okay? And if that doesn't work, try a different factor pair, or you could even change the order of how you've put them into the parentheses. Sometimes that helps. Of course, if they are both the same number, like in this case here, changing the order wouldn't make a difference. All right, now another way that you could do this is with the AC method. So the AC method is called the AC method because when you have a quadratic polynomial, it's of the form ax squared plus bx plus c. At least that's the standard form. And so when your polynomial is written like that, then you can identify the lead coefficient of the x squared term as your a. Like in this case, we have 3 here. And the c would be the last term, the constant term in your polynomial. Like in this case, we have positive 16 here. Now you multiply those together when you're doing the AC method. So the AC method is where you multiply a times c. In this case, 3 times 16 would be 48. And then you look for the factor pair that would give you 48 when you multiply them. But when you add them, would give you positive 16. And again, we think, okay, this is going to have to be a positive times a positive, so that when I add them, I will get a positive. Because I have a positive 48, the signs have to be the same. The positive 16 means those two same signs must have both been positive, right? So then you can start going through all your possible factor pairs. You could start with 1 and see that 1 plus 48 is 49. That's not what we want. You could do 2 times 24. That'll give me 26 when I add them. That's not what I want. And so on until you get the factor pair that works. Oops, that's not an answer. Should have been 3 times 16. That would give me 19. Still not hitting the mark here. Now, you might just think of, like for instance, 48, you might have thought about 6 times 8 or 4 times 12, but I like to go starting with 1 and then going down with each number that goes evenly into that, just to make sure I haven't missed anything. So next I'm going to try 4. 4 goes into 48 12 times, and when I add that, I get 16. So this is the factor pair. 4 and 12 is going to give me the positive 16 I need for my middle term in the polynomial. Okay, so I'm going to take my original polynomial and rewrite the first term and the last term. And then I'm going to take the middle term, which was positive 16x, and instead of writing it as positive 16x, I'm going to spread it out as positive 12x and positive 4x. So I'm just using these numbers here to expand that middle term. And the reason I'm doing that is because now I have one set of terms here and another set of terms here, and I can look at those sets individually and factor out the greatest common factor from each. So when I factor out the greatest common factor from the first set, I can factor out a common 3x, and that would leave x plus 4 inside the parentheses. Then for the second set of terms, I can factor out a common 4, and that would leave x plus 4 inside. Now, at this point, I have now, instead of 4 terms, I have 1, 2 terms. Okay, terms are separated by pluses and minuses. And when you see a number or two quantities multiplied together like that, this forms a single term. And then this plus sign right here separates it from the term 4 times x plus 4. So now that I have those two terms and I'm identifying them as two separate terms, I can look for a common factor. And the common factor here is the quantity x plus 4. So I can factor that out. When you get to this step, in fact, if your two sets of parentheses don't match, then either it's not factorable or maybe you made an error somewhere along the way. So now I'm just going to factor out the x plus 4 and then put the remaining elements into their own set of parentheses. And this is the answer. Okay. Yes, it is in a different order than what was written here, but remember, multiplication is commutative. So you can write things, 1 times, or excuse me, let's try 2 times 3 is equal to 6, and also 3 times 2 is equal to 6, right? The same thing goes for when you multiply quantities, whether you write it as quantity 3x plus 4 times quantity x plus 4, or if you write it like this, quantity x plus 4 times quantity 3x plus 4, they are equivalent answers and should both be considered equally correct.